Alright, welcome back. In this practice, we're going to place the polygon in a coordinate plane in the most convenient way, which means there are different ways you can do that, but we're going to use the most convenient way. So first, let's construct a coordinate plane and then look at our question 1. Question 1 says we're going to put a RT triangle, right triangle in the coordinate plane, and the legs are 4 and 3. If it's the most convenient way, I'm going to take a 0, 0 as our first point. And then the next one is 4. I can put a 4 here. 1, 2, 3, 4. And then put a 3 here. 1, 2, 3. Of course, you can switch this. You can put a 3 here. You can put a 4 there. Okay, you can switch that. Your choice. I'm going to put a 4 here and a 3 here. Now, last step, I'm going to connect it and right triangle. That's it. Next one, let's look at, we're going to put right angle. The dimension is 5, 4, length 5, width 4, or width 5, length 4. Depends on how you want to put it. Alright, so the dimension is 5 times 4, and we have 1, 2, 3, 4. This is a 5. I'm gonna put a little bit longer here, make it looking good. So this is a 5. As we said earlier, you can put it here as a 4, that as 5, okay? So 5, that's 1, 2, 3, 4, 4 here. And then, if you practice this on paper, make sure you use a ruler, make it look really good. Alright, this one is done. Next one, we're going to put isosceles triangle, so the legs is 6. Remember, you have different ways to do that, but it asks for the most convenient way. Alright, so I'm still using this 0, 0 as the first point. This time is 1, 2, 3, 4, 5, 6. 6 is here. 1, 2, 3, 4, 5. Oh, I need a little bit longer here. Oh, it's okay. 1, 2, 3, 4, 5, 6. It's wiggling, but that's okay. We can connect it. Alright, that is isosceles triangle, legs 6, legs 6, right here. Okay, we're going to make this game a little bit more interesting this time. We will not use real numbers. Instead, we're going to use our variables, letters, okay? These letters are our numbers. And we're going to put a triangle in the coordinate plane, and here is a coordinate. The first one is 0, 0. And the second one is a PQ. And next one is 2P0. Alright. Still the most convenient way. Coordinate plane, x-axis, y-axis. 0, 0. Let's graph the first one. 0, 0 right here. 0, 0 is A. And we want 2P0. So I'm going to say this is my 1P, this is a 2P. So 2P0 is right here, which is a C. So we just graphed C. Alright, let's look at our next point. It says a PQ. If this is a 2P, this is a P, so I'm going to take a P. Q, remember, you do not want to set a P and a Q as equals. You want to give a different value for Q. Therefore, I'm going to say, and here is my Q. You decide, okay? Yours and mine might not be the same, but we use the same concept. So this is a Q. Now, I want to grab a PQ. This is a P. P, go, 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 go. Did you see the dotted I'm making right here? I made a Q. Alright, so we found the PQ right here. PQ. And this is a B. Now, we're going to connect it. Alright, so we're just finishing plotting this. Now, we're not quite done yet. We're going to do a few review. Did you remember your distance formula and your midpoint and how to find a slope? Okay, we're going to put this all together, but we'll only do it once. Let's start with something really simple. Distance of AC. Distance of AC is really simple. Say 1p, 2p. Distance of AC is 2p. All right, let's look for distance of AB. If you want, you can pause this video and figure this out, work on your own, all right? So A is 0, 0, right? So I'm going to use our distance formula. I'm going to say P minus 0, open, close, squared, and Q minus 0, open, close, squared. So distance of AB is P squared plus Q squared. All right, go ahead and try BC. Remember, the distance of your x-coordinate squared plus distance of y-coordinate squared. Okay, all right. Now, let's try this. Let's find the midpoint. We're going to find a midpoint of BC. How about that? Did you remember midpoint formula is add your x-coordinates divided by 2. Add your y-coordinates divided by 2. Okay, so let's look at our x-coordinate is P plus 2P. That is 3P. Let's look at a y-coordinate. Q plus 0. Let's give a little bit of color. Q plus 0. That is Q. Now, we're done with this midpoint. Go ahead and practice midpoint of segment AB. Okay, let's see what else we have. Last thing we're going to practice is slope. Did you remember your slope formula? Slope formula says I'm going to find the difference of the y-coordinates divided by the difference of the x-coordinates. Okay, all right, let's do this. Which one should we work on? How about we work on slope of AB is a little bit simpler. Let's take something a little bit more interesting. Let's work on BC, okay? All right, slope BC. We're going to subtract the y-coordinates. So we have Q minus 0 on the top. And we're going to use, we did Q first, we're going to come back from P. We're going to say P minus 2P. Don't stop here. We're going to simplify. Q minus 0 is Q. P minus 2P is negative P. Therefore, slope is negative Q. I want to write beautifully. I want to do this. So slope is negative Q over P. I'm going to use a different color and put my solution right here. All right, we just finished. In the practices, we place the polygon in the coordinate plane. We use real numbers, and then we use these variables. We also reviewed our distance formula, midpoints, and the slope. Happy learning.